Okay, I think we are live. Hello, everybody, and thank you so much for joining or viewing our webinar that we're doing today. Today, I'm going to cover VISCO for the cosmetics industry, and my name is Taylor, and I work at ATAGO here in Japan. So I'll go ahead and get started. For anybody that joins the live, go ahead and put your questions in the chat and I can go ahead and answer them. But if you are watching this afterwards, feel free to leave a comment or give us a quick email at our email address. I'll go ahead and stick that in the chat now. Okay, perfect. So I'll go ahead and get started. Okay. So VISCO for the cosmetics industry. So when I'm talking about cosmetics, I'm going to be focusing mostly on shampoo and conditioner, and then I want to talk about creams too at the end, because I know a lot of people have questions about creams. But the cosmetic industry is a very, very vast industry with a lot of different products out there. So we're going to just focus on these three today, but if you have additional questions, feel free to let me know or reach out to us later. So viscosity and cosmetics. So viscosity is super important for cosmetics, pretty much any cosmetic, because it's really important because it determines how the product is actually going to perform when the customer gets it in their hands. So whether that's how easily it comes out of the bottle or how well it spreads, it also can affect different types of marketing as well. So like more high-end, luxurious, expensive products tend to be more viscous, whereas sometimes thinner, less viscous samples can be considered as more natural or sometimes even as less expensive, because that's just kind of how the market perceives these types of products nowadays. So definitely viscosity is something that you should be measuring as a cosmetic manufacturer, because it really influences how your end customer is going to perceive your product. So on ATAGO's side, we have a line of viscometers. So I'll introduce to you the VISCO team here. So we have two different types. The one on the left here is VISCO. That is like our original viscometer that we came up with, and it's designed to be more small, portable, still sits on the table, but you can easily pack it away into a carrying case, take it wherever you want, do some emergency viscosity readings somewhere else in the plant or whatever you need to do, but it's just designed to just kind of go anywhere. The one on the right is called the VISCO BL. That one's a little bit bigger, more lab style, meant to just stay on the tabletop. Has a few different spindles than the regular VISCO, and it's very comparable to other types of viscometers that are in the market currently. So if you are looking for more like of a lab grade style, you may want to consider the VISCO BL. They have very similar measurement ranges, but depending on your product, you might want to take a quick look at the specifications to just make sure if your product is particularly a low viscosity or particularly high, on which one is going to be best for you. But the ranges are pretty similar, and if you have any questions, you can just feel free to reach out to us, and then we can point you in the right direction in terms of which model you should get. So another thing I wanted to highlight about the VISCO series is that there's actually a temperature control version. Temperature control is really, really important for a lot of different industries, but especially for the cosmetics industry, it's good to kind of know the temperature of your sample, not only at room temperature, but other temperatures, to see how it's going to perform and how that product does under different types of temperatures as well. Sometimes, or not sometimes, always, when you're controlling the temperature of the sample, that's going to give you the most accurate viscosity reading, because temperature does affect viscosity measurements a lot. So if you're controlling the temperature of the sample, that's going to give you the most stabilized results. So VISCO, the regular one on the left, and package E, and VISCO BL on the right, package E, those are the temperature controller options. So it doesn't require any type of external water bath, or you don't have to heat the sample in the microwave or cool it down in a fridge or anything like that. You just kind of pop your sample into the chamber, into the temperature controller, put the VISCO on top, and then it does its thing. So it's very, very easy to use. I will be going over shampoo and conditioner measurement today with some videos. We're going to be focusing mainly on the VISCO, the one here on the left. Not temperature control, unfortunately, but if you have questions or want to see the temperature controller, feel free to reach out. So before we dive into the videos and whatnot, I wanted to talk about choosing a spindle, beaker, and RPM combo for your samples. I think this is a very, very popular question that we get from customers when they get the VISCO. They're just not really sure where to start. So I wanted to provide a little guide and guidance in the right direction. So if you have your sample and you have no idea what the viscosity is, this is just kind of a quick little guide to help you go in the right direction. Spindles and beakers and RPM, it's not a one-size-fit-all type of situation, so you may have to try a couple different combinations to find out which one provides the most stabilized measurement. But in general, if you have a lower viscosity product, you're going to want to choose a higher speed, or RPM. Use the wider or just larger looking spindles, but with a lower or a smaller beaker. So if you have a higher viscosity sample, where like you go to pour it out of the cup and maybe it doesn't really come out very easily, that's going to be considered more high viscosity. You're going to want to start with a lower speed, a smaller, thinner spindle, and a larger beaker. The good thing about the VISCO is there's not really that many spindles or beakers to choose from, so it's going to be not taking too much of your time to go through the combinations of testing with those real quick. It's really important to match your beaker and spindle correctly, though, in terms of sizing, so that you can have a nice distance, or like the correct distance between the spindle and the beaker. So you want less space between the spindle and the beaker if it's a lower viscosity product, and then you want more space between the spindle and beaker if it's going to be a higher viscosity product. So if you already kind of have an idea about what your sample should be measured at for an RPM, or if you have kind of an idea of what the viscosity measurement value is already, we have a few different, we call them maximum measurement value guideline charts in our instruction manuals, depending on which beaker you use. So there's only two, depending on which package you get anyway, but the basic model starts with only two beakers. But you just kind of go through and find your viscosity, and it will give you a guideline on which spindle to use and what RPM. So if you have any trouble with that, you can start. Like I said, it's not a one-size-fits-all type of situation, but if you have like a sample that's close to, let's say, this is kind of smaller here. So if you have a sample maybe closer to 11 million millipascal per second or centipoise, then maybe you'll want to stick with the A3 spindle and start at a lower RPM here. to see what's going to fit your sample specifically. Okay, so really quickly, I want to check in and see if I have any questions. Okay, nope, we can move on. Okay, so let's first start with shampoo. This is from a shampoo that we just had here at our office in Japan. And what we found was using the large beaker with spindle A2 or A3. I believe we use A3 in the video because that was a little bit more stable for the higher viscosity shampoo. And then we chose 100 for the RPM. So shampoo, like you can kind of get thicker versions or thinner versions. So you may have to, decide if you want to go with A2 or A3. So you'll want to try that out when you're testing your sample. Shampoo, it's really important to check the viscosity just to make sure that when you are actually in the shower or bath and you squirt it out into your hand, that it's not going to run out of it, or it's not going to come out of the bottle. Also, if it's not the right viscosity, it's not going to lather correctly when you're putting it in your hair. As I'm sure all of us have preferences on how foamy we want our shampoo to get, and if it's not consistent for the customer, then they're probably not going to be purchasing the product that many times. Also, viscosity of shampoo really affects like what container the company is going to choose. So depending on if they're pumping it out of a dispenser, it might need a larger nozzle if it's a higher viscosity, or maybe if it's a cap, you need to get a lower viscosity or the perfect viscosity to match the hardness of the bottle when you're squeezing it, so that the amount of force that you apply to the bottle is going to be appropriate and how much product is dispensed. So it gets pretty complicated, so that's why we should definitely be measuring the viscosity of shampoos. Next we have conditioner. It's a beautiful pairing to shampoo. That is, typically conditioners are a higher viscosity because, I see wow. Conditioner has a high viscosity, so don't read my description because there's a mistake, but conditioner actually has a higher viscosity because it is put onto the surface of the hair and kind of coats it, so that even after you rinse it out, it kind of leaves that nice coating to protect and moisturize. And so they have to have that high viscosity so that they can really penetrate into the hair and remain even after washed away. So the viscosity of conditioner is typically going to be used with a larger beaker because it's higher viscosity, and the A3 spindle. And then we're going to start at a higher RPM actually for this conditioner to get a more stabilized measurement. Okay, so I have a video for us to look at really quick. So let's get there. Okay. So first what we're going to do is start measuring some shampoo. Here we go. So when we're measuring highly viscous cosmetic products like shampoo or conditioner, we want to make sure that they're in the beaker correctly, that we're filling it up to the right line for whichever spindle that we're using. And then we're making sure too that when we turn on the VISCO and we go into the settings, that we have all the right settings for our product and what we have for our spindle beaker RPM situation. So I'm hoping you can see the VISCO display likes to flash because of the LCD screen when we're filming it, but you should be able to see all the right settings in there. And we've got around 7,600 for viscosity for shampoo. So we have conditioner, and you can see just how differently it comes out of the container. We have to really make sure that we're, kind of knocking the sample down. There's no air bubbles, that it's nice and level before we put the VISCO with the spindle into it. And then we just do the same thing. We turn it on and we make sure that we have the right settings. We've changed it to 250 RPM this time. And then we just start measuring, and it shouldn't take too long until we get a nice measurement value. So now we're at around 2,280 or about 2,300 centipoise for our conditioner. Okay, perfect. Let's go back to our slideshow here. Okay. So we have talked about shampoo and conditioner a lot. Now we need to talk about creams. I'm gonna quick check to see what we have going on. Okay, no questions right now, so I can keep going. Right, perfect. So let's talk about creams. So creams, I think, is the most difficult thing to measure in the viscosity world. Of course, there are a lot of different types out there. And when it starts to get tough is when you run into a very specific type of cream that we like to call a non-Newtonian liquid, but specifically a pseudoplastic. So the thing about pseudoplastics is that the viscosity decreases as you increase the force applied to them, or the shear rate. So if you can imagine, you have maybe like a body butter is a good example. You put the body butter on your skin, and as soon as you kind of go to rub it in, it very, very quickly, the viscosity decreases and becomes non-existent and absorbs into your hand, right? So it's because you're applying that force to it. It's changing from a nice viscous cream to a very, very low viscosity cream to go into your hand. So if you can imagine the viscometer, especially the ones that ATAGO have, it's a rotational type viscometer, and it uses a force applied against the liquid to measure the viscosity. So as soon as we apply any force to a pseudoplastic type of cream, that's when it starts to cause this effect called drilling or tunneling, and it actually changes the viscosity of the sample as it's turning. So sometimes it's kind of like it's pushing it away from the spindle in a way and creating like this air gap, or it's kind of mixing it and making it even lower of a viscosity. So all of these things are going to make it hard to get an accurate or stable reading with a rotational viscometer in some cases. So you're going to want to, if you have this type of sample, you're going to want to first really check and make sure that all the spindle, beaker, and RPM combinations are truly not going to work for your sample before you consider other options. Also, another thing that you can try is to use the temperature control method to see if maybe increasing the temperature a little bit or decreasing the temperature a little bit of the sample will help you get a more stabilized reading. So there are some other things that you can try before you look for a different viscosity meter for that type of cream. So there are other types of viscosity meters out there in the world, like there's a falling metal ball one, or capillary, or there's manual viscosity meter tests that you can try too. But I think like the cosmetic world is pretty set that the easiest way is to use a rotational viscometer, similar to the VISCO, even though there are some creams that it is harder to measure with. Okay. Perfect. So I am at the end of my presentation. Thank you so much for watching and getting this far. Like I said, that we're always here to answer questions and see, kind of what we can do to help you with your specific sample. So just feel free to reach out to us. We do quite a few webinars. We have a lot already up on our channel, but we do at least one per month. So if you want to give us a like or subscribe so that you can see more, we would love it if you could join us again in the future. Okay, well, that will bring me to the end of my presentation. But I hope you guys have a good rest of your day, and we will see you next time.